Okay, hi everyone. Today I am starting the unit 1, that is circuit breakers. Okay, in first unit we completely study about the circuit breakers. Okay, in this unit first we study about what is meant by circuit breaker, what is the need of circuit breaker, and what is the working principle of circuit breakers, and what are the types of different types of circuit breakers. Okay, that is the total unit. Okay, in this unit we study about overall circuit breaker operation and types of a circuit breaker. Okay, first we know what is meant by the circuit breaker. It means in the normal condition it is just like as a switch. Okay, it also break the circuit. In that name, in that name we know the break. Circuit break, it means it break the circuit. Okay, circuit breaker is used for break or make the circuit. It is used for break or make the circuit under normal and abnormal conditions. Okay, normal conditions means the no fault condition, and abnormal conditions means the if any fault will be obtained in the circuit or the line. Okay, in that case it is also used for break or make the circuit. Okay, it is just like as a switch under normal operating conditions. Okay, under normal operating condition it is just like as a switch, but there is some difference between the circuit breaker and the switch. Okay, before going to study the circuit breaker, first what is the difference between the switch, fuse and circuit breaker? We well know about the switch and the fuse. In daily life we are using the number of switches. Okay, and also we see the fuse also in your home. Okay, the switch is used for on and off the electrical circuit by manually we use the switch as on and off the electrical circuit. Okay, under normal operating conditions only. Okay, that is the switch. Okay, first next one is the fuse. Fuse means that it is a overcurrent protective device. Overcurrent protective device. If any overcurrents are obtained in the circuit or the line, the fuse is melted. Okay, if any overcurrents are obtained in the line, the fuse melted, but it does not make the circuit. Only it break the circuit under faulted conditions. Okay, it does not make the circuit, but it is suitable for the small ratings only, and also it is suitable for the small ratings only. Okay, that is the fuse. Next, coming to the circuit breaker, it is also an overcurrent device like as a fuse, but if any overcurrents are obtained in the circuit, it break or make the circuit. If any overcurrents are obtained in the circuit, it break or make the circuit. Okay, that is the difference between the fuse and the circuit breaker. Fuse only break the circuit under abnormal conditions, but the circuit breaker is used for break or make the circuit under normal and abnormal conditions. Okay, and also it will be used for on and off the electrical circuit under normal and abnormal conditions, just like as a switch. Okay, that is the difference between the switch, fuse and circuit breaker. Okay, understand? Next one is the it is used for on and off the electrical circuit manually and automatically under overcurrents are obtained in the circuit. The circuit breaker is used for on and off the electrical circuit manually and automatically under overcurrents are obtained in the circuit. Okay, next one is it is also known as a miniature circuit breaker, that means the MCB. Okay, it is an electromechanical device. The circuit breaker is the electromechanical device, okay, to protect an electrical circuit from overcurrents. Okay, the circuit breaker is used to protect the overcurrents are obtained. If any overcurrents are obtained, in this case we are using the circuit breakers. Okay, next one is under normal operating conditions, that means the no fault condition, the MCB is used just like as a switch. Okay, under normal operating condition, no fault condition, the circuit breaker is used as a switch for on and off the electrical circuit. Okay, next one is it may be operated manually or automatically. Okay, it is used for operating manually and automatically for faulted and unfaulted conditions. For faulted and unfaulted conditions. Okay, the circuit breaker is used for break or make the circuit manually and automatically. Okay, it is more sensitive to the fault than fuse. When compared to the fuse, it is a more sensitive device. Okay, that is the basic introduction to the circuit breaker. Okay, next, how the circuit breaker is operated. Next, how the circuit breaker will be operated under abnormal conditions. Okay, that will be discussed by using this figure. Okay, in this we are using the bus. This is the bus. Okay, this arrow mark line indicates the bus. In that bus we are connecting the feeder. Okay, in that bus we are connecting the feeder. Okay, this is the bus. This is the bus. Okay, this is the bus. Next one is this is the feeder line. Okay, this is the bus and this is the feeder line. If that feeder line will be connected to the bus, the feeder line is connected to the bus. Okay, in that feeder line we are connecting the CT. This is the CT. CT means the current transformer. The secondary of this CT is connected in the feeder line. Okay, in that feeder line we are connecting the circuit breaker. In that feeder line we are connecting the circuit breaker. Okay, the secondary of this CT is connected to the relay coil. Bhargavi, కనిపించట్లేదా? స్లైడ్స్ రావట్లే. అవునా, వెయిట్ వెయిట్. అమ్మ Okay, next, how circuit breaker operated. Okay, this is the diagram for the circuit breaker operation. In that we are using the bus. This is the bus. Okay, next in that bus we are connecting the feeder line. This is the feeder line. Okay, this is the feeder line. This is the bus. Okay, in that bus we are connecting the secondary of CT. This is the secondary of CT. Okay, next one is the in the feeder we are connecting the circuit breaker. That circuit breaker is connected to the tripping coil. That circuit breaker is connected to the tripping coil. The secondary of this CT is connected to the relay coil. This is the relay coil primary. Okay, the relay coil secondary will be connected to this potential transformer. The relay coil secondary is connected to the potential transformer. Okay, in that relay coil we are connecting the one tripping contact. This is the tripping contact. The total tripping circuit is connected by this DC supply. By this DC supply. Okay, this is the construction of a circuit breaker. Okay, first we are taking the one bus. Okay, first we are taking the one bus. This is the bus. We are taking the bus. Okay, this is the bus. In that we are connecting the one feeder. This is the feeder, and in the feeder we are connecting the CT also. In the feeder we are connecting the CT. Okay, in the feeder we are connecting the CT of secondary and also circuit breaker. That circuit breaker is connected to the tripping coil. This is the tripping coil. The tripping contact is connected to the relay coil. The tripping contact is connected to this relay coil. Okay, the primary of the relay is connected to the secondary of this CT, and secondary of relay coil is connected to the potential transformer. Okay, this is the construction of a circuit breaker. Okay, next, if any fault obtained in the feeder line, if any fault are obtained in the feeder line, sorry, if under no fault condition, no fault condition means the no current will be flowing through the relay coil. Therefore, the tripping contact does not closes. Then there is no tripping coil energization. Then that circuit breaker is in the open condition. Next, suppose if any fault will be obtained in the feeder line. Suppose the fault will be obtained at this point. In that case, the current flowing through the CT. Okay, under fault condition, the fault current is flows through the CT secondary. Okay, the fault current is flowing through this CT secondary to the relay coil. Okay, therefore, relay coil MMF increases. Therefore, the relay coil MMF is increases. The fault current flows through the relay coil by secondary of the CT. Therefore, the relay coil MMF is increases. MMF means the magnetomotive force. Okay, that is proportional to the NI. MMF is proportional to the N into I, where N is the number of turns and I is the current. N is the number of turns and I is the current. Suppose the current I is increased, automatically the MMF of this relay is increased. If the MMF of this relay increases, the tripping contact is in closed position. Then automatically the supply is going to the tripping coil. Then this coil is energized. Then the circuit breaker is operated. This is the under fault condition. Suppose if any fault obtained in the feeder line, the fault current is flows through the CT secondary to the relay coil. This is the CT secondary. The fault current is flowing through the CT secondary to the relay coil. Therefore, the relay coil MMF is increased. MMF means the magnetomotive force. The MMF is increased. Okay, the MMF is directly proportional to the N into I. okay, where N is the number of turns and I is the current, okay, and I is the current. Suppose the current increases, MMF is automatically increased. Then the tripping contact, this is the tripping contact, then the tripping contact is closed. Then while connecting the DC supply, automatically the tripping coil is energized. This tripping coil is energized, then the circuit breaker will be operated. This is the faulted condition. This is the operation of a circuit breaker. Okay, when overcurrents are obtained, when overcurrents are obtained, and then automatically the circuit breaker is closed. Automatically the circuit breaker is closed. This is the normal operation of a circuit breaker. Next, coming to the working of a circuit breaker, this is the basic diagram of a circuit breaker. In that we are having the various components are there. Various components are there. First one is the fixed contact. First one is the fixed contact. This is the fixed contact. Okay, this is the fixed contact. The fixed contact. Second one is the moving contact. Second one is the moving contact. Next one is the arc runner. Next one is the arc runner. This is the arc splitters, and this is the bimetallic strip. This is the bimetallic strips. This is the latch point. By using this latch point, we connect the bimetallic strip, and this is the operating mechanism, that means the switching operation. This is the operating lever, and this is the tripping coil. This is the tripping coil. Okay, in that we are using the fixed contact and moving contact. In between the fixed and moving contact, there is a some gap in the normal operating, sorry, the fixed and moving contacts are close together under normal operating condition. If any faults are obtained, in that case, the fixed contact is move away from the fixed contact. The moving contact is move away from the fixed contact by using this metallic strip. Okay, by using this metallic strip, the moving contact is move away from the fixed contact under faulted condition. Okay, how the moving contact is move away from the fixed contact means the when the fault current is flowing through the tripping coil, automatically some heat will be developed. By that heat, the bimetallic strip will be bended. By using that heat energy, the bimetallic strip is bended. Then automatically, by bending of this bimetallic strip, the moving contact is pull away from the fixed contact. If the moving contact is pull away from the fixed contact, an arc will be struck in between the fixed and the moving contact. An arc is struck in between the fixed and moving contact. Okay, by using these arc runners and arc splitters, we control this arc. Without controlling of this arc, the contacts of these fixed and moving contacts of the circuit breaker may be damaged. For that reason, we definitely minimize the arc by using the arc runners and the arc splitters. Okay, the latch point is used for connecting the bimetallic strip. The latch point is used for connecting the bimetallic strip. Okay, the next one is the arc splitters. By using these arc splitters, we control or we split the arc for reduction or reducing of the arc. Okay, next one is, this is the operating mechanism. This is the operating mechanism. By using this operating mechanism, we on and off, and that means the springing action. Okay, this is the operating lever. These two are used for the operation of a on and off conditions. Okay, these are the various components or practical view of a circuit breaker. This is the various components. First one is the fixed contact. Next one is the moving contact. Under normal operating condition, the fixed and moving contacts are together to each other. There is no any gap between the fixed and moving contact under normal operating conditions. Next one is the trip coil. By using the trip coil, we close the tripping circuit. We close the tripping circuit. The trip coil is energized by the relay. Okay, that relay operation will be studied in the second unit. Next one is the bimetallic strip. By using this bimetallic strip, the moving contact is pulled away from the fixed contact. By using this bimetallic strip, the moving contact is pulled away from the fixed contact. Okay, how the bimetallic strip will be pulled away from the fixed contact. How the bimetallic strip is used to move the moving contact means when the tripping coil energized, automatically some heat energy will be developed. By using that heat energy, the bimetallic strip is bended. Then automatically by bending of the bimetallic strip, the moving contact is pulled away from the fixed contact. Okay, that is the purpose of a bimetallic strip. Next one is the arc splitters. What is the use of arc splitters? Means the we reduce the arc. We control the arc. Next one is the latch point. By using this latch point, we connect the bimetallic strip. Next, operating lever are used for the operation of on and off springing action. Okay, that is the construction and various parts of a circuit breaker. Next, coming to the working, when overcurrent flows in the circuit breaker, that means faulted condition, the bimetallic strip gets heated. Okay, when overcurrents are obtained, then automatically some heat energy will be produced. By using this heat energy, the bimetallic strips are heated. Okay, and causes to deflect due to the bimetallic strip. uh, this is the figure A and the figure B. This is the bimetallic strip. This is the normal operating condition of a bimetallic strip, and this is the abnormal conditions or faulted conditions of a bimetallic strip. When overcurrents or flows in the circuit breaker, automatically the bimetallic strip get heated and it will be bended. Okay, due to that will be shown in this figure. Okay, due to the bimetallic strip deflection, the trip bar move and release the latch mechanism. Okay, and hence the contacts open under springing mechanism. By bending of this bimetallic strip, automatically the moving contact is move away from the fixed contact. Then the circuit breaker is operated. Okay, this is the open contact. Okay, that is the bimetallic strip operation. Next, the arc is produced during the separation of a contacts. When under abnormal conditions, the fault will under abnormal conditions, the moving contact is move away from the fixed contact. Okay, in this case, the moving contact is move away from the fixed contact means there is a some air gap between the moving and fixed contact. In that air gap, the arc is produced. Okay, an arc is produced during the separation of contacts at overloads as well as a short circuit conditions. Okay, this arc is moved into the arc splitters. This arc is moved into the arc splitters. Then arc broken into particular arcs in the arc chutes and they no longer exist due to the voltage drop of this arc. That means by using the arc splitters, we will split the arc. Then automatically the arc will be reduced. Okay, next separation of contacts of a circuit breaker. Okay, this is the diagram. By using this diagram, we easily understand how the circuit breaker will be operated. The main components in the circuit breaker is this is the fixed contact and this is the moving contact. The fixed and moving contacts are together to each other under normal operating conditions. Okay, the fixed and moving contacts are together to each other under normal operating conditions. If any faults are obtained by using the metallic strip, by formation of the heat energy, the bimetallic strip is bended. Automatically, the moving contact is move away from the fixed contact. If the moving contact is move away from the fixed contact, there is some gap will be produced. This is the air gap in between the fixed and the moving contact. There is some air gap will be obtained in the fixed contact and the moving contact. In that air gap, due to the ionization of the current, some arc will be produced. Due to the ionization of the current particles, some arc will be struck in between the moving and fixed contact. If any fault will be obtained, in that case, automatically the moving contact is move away from the fixed contact. The moving contact is move away from the fixed contact. If fault will be obtained, automatically the faulted current will be flowing through the tripping coil. Then the MMF will be increases. The MMF is directly proportional to the N into I. N is the number of turns and I is the current. If the current increases, automatically the MMF of the relay coil is increased. If the relay coil MMF increase, automatically the tripping coil is closes. Then the tripping coil circuit is closed. Then the tripping coil is energized. Then the circuit breaker will be operated. In this process, some arc will be produced in between the gap of fixed and moving contact. Due to that gap, some arc will be struck. Okay, that arc will be damage the fixed and moving contacts because the arc having the the arc having the high amount of heat energy. Due to that heat energy, the contacts of the circuit breaker may be damaged. That's why first we will reduce the arc. We will reduce the arc. By using the arc reduction process in that circuit breaker, we are using the arc splitters. By using the arc splitters, we control the arc. Okay, this is the basic diagram for working of a circuit breaker. Okay, the basic construction of a circuit breaker requires separation of a contacts in an insulating fluids and a serves two functions. Okay, first one is the executes the arc drawn between the contacts. When the fault will be obtained, the moving contact is move away from the fixed contact. Then the arc is struck in between the contacts of the circuit breaker. Okay, next provides insulation between the contacts and from each contact to the earth. Okay. Next, the commonly used insulating fuels. The commonly used insulating fuels means that if there is some air gap between the fixed and the moving contacts. In between the air gap, we are using the some insulating mediums. Then we will reduce the arc within a short time and we give the protection for the circuit breaker. Otherwise, the circuit breaker is damaged and then frequently we replace that circuit breakers. Okay, that's why we are using the insulating medium in between the fixed and the moving contacts. Okay, we are having the some of the insulating fuels are there, that is the air at the atmospheric pressure and compressed air, oil produced hydrogen for the arc extension, ultra high vacuum, sulfur hexafluoride. Okay, that is the some of the fluids are used. Next one is the properties of a fuel. The properties of the fuel is the high dielectric strength, high thermal stability, arc extinction ability, chemically stable and commercially available at a moderate cost. Okay, these are the various properties of a fuel. First one is the high dielectric strength, next one is the high thermal stability, next one is the arc extension, chemically stable, commercially available at a moderate cost. Okay, thank you. Ma, ma.